on in. We're going to talk about geometric series today. Have a seat. So today we want to talk about the sum of a finite geometric series. Let's write down a general geometric series first. So geometric series, remember, is a series where each term is a constant multiple of the previous term. So if we call the first term A, then the next term we could say would be AR, where R is the constant multiple. The next term in the series would be AR squared. And this would continue up to, let's go all the way up to A times R to the n minus 1. Now the reason I want to stop at n minus 1 is because I want there to be n terms in the series. So if you count the number of terms here, this is actually r to the 0. If you count from 0 up to n minus 1, that's n things. So this is my geometric series, and what I want to learn is a formula for the sum of that series. So to find a formula for the sum, we're going to use a trick. This is a great trick, and it applies in lots of different circumstances, so it's a good one to remember, but it's especially good for geometric series. If we take Sn, which we don't know, and multiply Sn by the constant multiple r, we get r times Sn. That multiplies each term here by r, so a multiplied by r is ar, and ar multiplied by r is ar squared, and ar squared multiplied by ar is ar cubed, and so on, plus the term that comes before here multiplied by r will be ar to the n minus 1. And finally, the last term multiplied by r will be a times r to the n. So basically, each term in the original sum been multiplied by r, moved over 1, right? We see this sort of moving over. And we have this one new term, ar to the n, which you get by multiplying ar to the n minus 1 times r. All right, so why is this a good trick to do? Well, let's now subtract these equations, the bottom one from the top. So if we subtract the equations on the left-hand side, we get Sn minus r times Sn. And if we subtract the equations on the right-hand side, the terms that are repeated in the top and bottom will cancel. And so the only terms that will be left are the first term here, a, and the last term, minus a r to the n. So that's why this is a great trick, because it takes this series that's who knows how long and makes all the middle terms disappear so that we only have the first and the last term now. We're almost finished. Remember, we're trying to find Sn, so now algebraically we want to solve this formula for Sn. We can do that by factoring out Sn. Sn times 1 minus r. And remember, r stands for that constant multiple that was part of the original geometric series. Equals, well, let's factor out an a here. So that's in both terms, a times 1 minus r to the n. And the last step in solving for Sn is to divide both sides by 1 minus r. So Sn equals a times 1 minus r to the n over 1 minus r. And of course, this only works if r is not equal to 1, because otherwise that would be dividing by 0. So this is our resulting formula for the sum of a geometric series. And it's worth pointing out that the original geometric series had the first term equal to a, right? That's what a means. It was the first term in the geometric series. And the constant multiple that made it a geometric series was called r, and the letter n stands for the number of terms in the series. So the number of terms equals n. And that's it. That's a formula we can use for any finite geometric series.